Hello everyone, it's Mrs. Davitt here, and today we're going to talk about using trigonometric ratios to find missing angles. So just keep in mind that we've already talked about 3 trigonometric ratios in class: sine, cosine, and tangent, which are represented by these ratios of sides in relation to angle theta. We've also talked about the acronym SOHCAHTOA that just helps us remember those formulas more quickly. So you should have all of that information in your notes already. Keep in mind also that it's super duper important that your calculator is in degree mode. If it's not, you're going to have trouble getting the correct answers even if you're doing all the correct work. So make sure you check that, and if you need any help checking that, let me know and I'll be happy to show you how. Now, yesterday and in our previous examples, we used these 4 steps to solve our trigonometric functions. And we will actually use the exact same 4 steps today, although the solving step will look a little bit different. So we're still going to label our sides, we're still going to figure out which ratio to use, we're going to write an equation, and then we're going to solve. And as we go through some examples, you'll see how this process changes a little towards the end. So here are 2 examples that we're going to consider today, and I always just jot my acronym SOHCAHTOA somewhere on my page as I'm getting ready to tackle some examples, so there it is. I also want to make sure that I start off the same way I always do in any trigonometric function question, and that is by labeling my sides opposite, adjacent, or hypotenuse. Now notice here that this time we don't know this angle, but no big deal. We're still going to label in relation to this angle that we seem to be interested in. So I'm going to go ahead and do that, and hopefully we would identify that this 6 is the side opposite theta, the 15 is the hypotenuse, and this side here that it doesn't look like we have any information about or even want any information about, that's the adjacent side. Okay, so looking at this triangle, if I'm trying to connect this 6 and this 15, that is the O and the H, the opposite and the hypotenuse. I must be interested in sine. So let's go ahead and jot down that formula. So far, everything should feel very similar to what we've done in the past. But you're probably already noticing, well, usually I'm trying to find a side length, and this time it looks like I know both of the side lengths and I'm trying to find an angle. So what changes? Well, when we go to the step of writing our equation, what changes is what we plug in. We do not know the angle, so we leave theta. But we do know both sides, so we have our fraction, 6 over 15. Now, this is where the work changes. So we're at the solving step. We've got everything plugged in and we're ready to go. Typically, at this step, we would put this sine of theta over 1, and we would have to cross multiply to solve because we would be looking for some piece of information in this fraction. But that's not the case anymore. We know both of the side lengths in the fraction, they're 6 and 15, and what we don't know is the angle. So we need to figure out some way to solve for theta. So how do we do that? Well, keep in mind that the sine of theta is a function. We are doing something to the angle. What we are doing is we are telling the calculator to look up the ratio of the opposite side to the hypotenuse for some angle. Well, if I want to find the angle, I have to work backwards. So the process is going to look very new. But hang on tight, okay? Anytime we want to solve something, we do what's called the inverse operation. If I see addition in an equation, the inverse is to subtract. If I see multiplication, the inverse is to divide. If I see a square, the inverse is the square root. Well, we are going to do an inverse sine function to undo the sine function. So it's going to look really strange. It's going to look like a sine to the -1 power, but it's not actually an exponent. It's called the inverse. Follow along with me for a second here. This is what this work looks like. What I do to one side of the equation, I do to the other side. So I am applying what's called the sine inverse function to the entire left-hand side of the equation and the entire right-hand side of the equation. Now just keep in mind what an inverse operation does. It undoes, right? So sine inverse should undo sine. So why is that helpful? Like, it looks like I just made it messier, right? Well, if sine inverse undoes sine, all we will have left on this left-hand side is theta. So that will cancel out. And theta will equal whatever in the world the sine inverse of 6 over 15 is. Now, think about what this is doing. Sine typically takes an angle and spits out a ratio. What we're doing is we're saying, hey, let's work backwards. Here's the ratio, 6 over 15. Give me the angle. So the calculator actually has a button that will do all of this work for us. So even though it looks quite strange, it's going to be a very quick process to calculate. If you look at your sine button, right above the sine button is a sine inverse button. By the way, this can also be called arc sine. It just means the inverse. Okay, so if you look at that sine inverse, you just hit second and the sine button, and that sine inverse will pop up on your screen. And now instead of typing in the angle, you'll type in the ratio, 6 over 15. Hit enter, and voila, we should get our angle. Now, if you didn't get that, you might not be in degree mode, so just go ahead and check that if you need to. So that's our first example. The process looks really strange, but it's actually a lot quicker than some of the other problems we did, because as soon as we know what we're typing in, the calculator is going to do a lot of the heavy lifting for us. So let's look at the second example. Taking a look at this triangle, I know these two sides. I seem to want to know this angle. So in relation to that angle, I'll label my sides opposite, adjacent, and hypotenuse. I notice that I'm relating the O, opposite, and the A, adjacent. So that must be my tangent, TOA, O and A. So I'll write down my tangent formula. Once again, plug in the values that I know. I do not know the angle, but I do know the two sides. So theta stays in the angle spot. My two sides are 12 and 9. Now I know it's strange, but we want to undo tangent. Why? Because theta is trapped inside of the tangent function. So the way we undo tangent is with tangent inverse, folks, and what we do to one side of the equation, we do to the other. So it looks strange, but all we're going to do is apply that inverse tangent, or arctan, to both sides of the equation. On this side, something very nice happens. Tan and inverse tan will cancel out and just give us theta. And what is theta equal to? Well, it's equal to whatever we have left on this side, tangent inverse of 12 over 9. It looks strange, but keep in mind the calculator can do all of this for us. So the calculator is going to take this information and say, okay, for what angle, theta, does the ratio of the opposite to the adjacent equal 12 over 9? And if you type that into your calculator, right away it will spit out 53.13 degrees. So I hope that gives you an idea of how to tackle these inverse trigonometric functions to find missing angles. Thanks for joining me.